we're going to look at some worked examples on thermal physics. Cool it. Here we have a bottle of McDonald's Coke. So we have 1 kilogram or 1 litre of this McSugary Coke at around 10 degrees from the fridge. We want to find out how much ice is needed to be added to bring the temperature down to 0 degrees. You need to know the latent heat of fusion is 334 kilojoules per kilogram, and the specific heat capacity of water is 4,200 joules per Kelvin per kilogram. So basically what happens is that the ice is put into the Coke, the ice melts, and in making the ice melt, the Coke will lose some of its heat, its thermal energy, to melt the ice. So basically the energy which is lost by the Coke will be the energy which is absorbed by the ice cubes. So the energy lost by the Coke is delta Q, which is m, which is the mass of the Coke, C delta T, is equal to the energy absorbed by the ice cube, which is ml, because we're basically melting the ice cubes. So m is 1 kilogram, C is equal to the specific heat capacity of water, T is the temperature change, delta T. This is equal to the mass of the ice that we don't know, times by the latent heat of fusion of the ice. So this is what we have. So we basically just have to solve for m. So what I did was I divided by 1000 first, and we're left with 42 is equal to 334 m. So divide both sides by 334, so m is equal to 42 over 334, which is 0.126. In other words, it needs 126 grams of ice to bring the temperature of Coke from 10 degrees down to freezing. We have a cold metal put in some very hot water. So let's say we have half a kilogram. So we have the boiling water, which is at 100 degrees, and we drop in some metal, which will lower the temperature, and we need to find the final temperature X. So we'll do the working here. Here again, the energy which is lost by the water is going to be the energy that is gained by the metal. So the temperature of the water will come down, the temperature of the metal will go up, and they will arrive at the same temperature. So delta Q is equal to mc delta T for the water, which is equal to mc delta T for the metal. Notice that the masses are different, the specific heat capacities are different, and the change of temperature is going to be different for each. This is the energy which is lost by the water. This is the energy that is gained by the metal. We'll put the values in. The mass of the water is 0.5. The specific heat capacity is 4,200. Delta T, we don't know. We'll leave that as delta T for the water just now. The mass of the metal is 0.22. C is equal to 450. And delta T is the change of the temperature of the metal. But these delta T's are different values. So what is going on here? In the water, we start at 100 and we end up at a new temperature, X. With the metal, we start at 20 degrees and we go up to X. Of course, the metal and the water end up at the same temperature. So what is the change of temperature of the water? Well, it basically starts at 100 and then it ends up at X. So the change of temperature is 100 minus X. Here the change of temperature is X minus 20. So we can put those values in there, and you basically then have to solve for X. Get all the X's on one side, and we have X is equal to 96.4 degrees. So this metal doesn't have a big effect on the temperature of the water. It just brings it down from 100 degrees to 96 degrees.